Okay, in this video I'm going to show you how to do another question with variable acceleration. So here we've got, again, velocity in terms of t, a piecewise function with some unknown constants here. So we're given that v equals 4 when t equals 12 as well. Okay, and I want to show that c equals 12 first of all. So to do that, I need to look, okay, c is to do with 6 to 10, over here is to do with 0 to 6. So I see there's an overlap here between the 6, so that means that when t equals 6, v equals, it's going to fit into that one definitely, 6 squared minus 4 times 6, and it also is going to equal c. Okay, t equals 6, v equals c, t equals 6, v was also equals to t squared minus 14. So that means, which we can easily work out, that equals 12. So c equals 12, done for I, for the first part. Okay, then it asks us to calculate the values of a and b, and briefly describe the motion in the interval 10 to 15. So we're going to need to use two different facts here because we've got two different unknowns that we want to work out. So first of all, we can say, all right, let's look at when t equals 10. So when t equals 10, we know that this one is true. V equals c, which we've just worked out, is 12. And it also equals this. So 10a plus b. So 10a plus b equals 12. That's going to be one equation that we're going to be able to use. Okay, we also can think about when t equals 12, which we're given here that v equals 4, we're given in this fact, but it's also going to be within this part, so it's going to be 12a plus b. Okay, and that's going to be another equation. Now I can just solve those two simultaneously, so I can do, I probably want to do 2 subtract 1, which will give us 12a plus b equals 4, subtracting 10a plus b equals 12, so that gives me 2a, 0 equals -8, so a equals -4. Okay, that's 1 there. Then I'm just going to substitute that back in to, let's say, 1, and I end up with 12 equals 10 times -4 plus b, which is going to give us that b equals 52. Okay, so those are our two values. Then it says, briefly describe the motion of the insect in the interval. So its velocity is -4t plus 52. So that a there, that's its acceleration. Because think about, if we were going to differentiate that, we would just be left with -4. So all we need to say here really is that the insect moves with constant deceleration. So the important thing to say there is that it's constant and that it's negative, it's deceleration. Or it decelerates at a constant rate or something like that. Because it does say briefly describe, so but that's the most important stuff there. Okay, part 3 then, calculate the values of v for t equals 0, t equals 2 and t equals 4, and then sketch the vt curve for the motion of the insect. Okay, so t equals 0, we just need to sub it into there, v equals 0 squared minus 4 times 0, well, that's clearly 0, t equals 2, v is 2 squared minus 4 times 2, okay, that's going to be -4, and when t equals 4, v is 4 squared minus 4 times 4, which is again 0. Okay, then if we're going to sketch the curve, we want to, draw my axes here. Okay, I don't need too much on this side because I'm only going between 0 and 6. So the time is always on the horizontal axis. Okay, and we've got a quadratic. It's going to be something like this. Okay, and then because it's positive quadratic, I know that's going to be the shape. I know that it crosses there at 0. That's going to be 4 because of this, and then down there I'm going to know that's 2 minus 4 as well. But I think that's all that you really need to mark there. Okay, and then 6 is going to be somewhere here. All right, then the last bit says calculate the distance travelled by the insect in the interval between 0 and 6. Because it's distance travelled, that means we want the total area. So we want this area and we want this area. If it was displacement, then yeah, we would allow those to cancel. But because we want distance travelled, we do not want this negative and this positive to cancel each other out. So we're going to have to work them out separately. Okay, and we're going to have to integrate then in 2 parts. So first of all, we want to find this area. If we label this area A and this area B, that might help. So A is going to be the integral of this function, which we know is t squared minus 4t, with respect to t, between 0 and 4. Okay, then if I integrate that, I am going to raise this power by 1, which gives me t cubed, then dividing by 3 by the new power, it gives me 1/3. Then I'm going to raise this power by 1, which is going to be t squared, divide by 2, 4 divided by 2, leaves me with 2. No constant needed because it's a definite integral, we just need to put our limits on there. Okay, then we're going to substitute in our limits. So we have 1/3, 4 cubed minus 2 times 4 squared. That's our upper limit. And then we're going to minus the lower limit. That's just going to equal 0. That's going to be nice and easy. And we are going to end up with 1/3 of negative 32/3. So that's negative as we expected. When we go to add up, we're going to want to find the absolute area, but for now it doesn't matter too much. And now let's look at B. It's going to be the integral of the same function because it's all between 0 and 6 up here. So it's the same function, we're only separating it because we don't want to muddle up our positives and negatives. So it's still t squared minus 4t dt, but this time it's between 4 and 6. So we're going to end up with this same thing over here, but this time we're going to substitute in, well, let me write it out. So this time the limits are 4 and 6. So what we're going to do is substitute in our upper limit first, and then we are going to subtract the lower limit, which is going to give us okay, so if we substitute this one in, we actually end up with 0. So that's going to be 0 minus this same 32/3. So that's going to give us 32/3 as a final answer. So this is negative 32/3. This is positive 32/3. So the total is just the absolute values added up. So 32 over 3 plus 32 over 3, which is 64 over 3, which is roughly 21.3 meters, so 3 significant figures.